In this video, we'll learn about the basics of load balancing in Azure. And the main goal that we have with load balancing is high availability. We're going to create multiple virtual machines, for example, and then we're going to use a load balancer to distribute all of the incoming traffic across those virtual machines. And the basic idea here is that if one or more of those virtual machines fails, the load balancer can detect those failures and stop sending traffic to those failed virtual machines. So let's start by understanding the basic components of a load balancer. And really the first thing that we need to do, assuming we are doing a public load balancer, is to set up a DNS hosted zone. So let's assume that the name of our website is example.com. Well, if somebody wants to send traffic to our website, they're going to have to issue a DNS query that basically says, how does my computer get to example.com? We've got to tell the internet about this load balancer. We've got to tell the internet which traffic should be sent to this load balancer. So we're going to have to configure a public hosted DNS zone. So assuming that that part is all done, and that's really not part of your load balancer, by the way, that's something that you'll have to set up in DNS. But assuming that that is all done, and now traffic starts to come into example.com, and those requests are going to be directed to the IP address of the front end of our load balancer. And you'll see this when we do our demo. We're going to create a load balancer, we're going to create a front end, and we're going to assign a public IP that is reachable on the internet to that front end. And so now the load balancer itself is going to be reachable from the internet. And again, this all assumes that you're going to be using a public load balancer. If you go into the Azure portal and you choose a public load balancer, it has the ability to have a public IP. If you choose an internal load balancer, that's only going to work inside of your Azure virtual networks. So we now have an IP address that is reachable on the internet, and we are going to set up some rules. And the rules that you'll see in the demo will basically say if traffic comes in on port 80, which is HTTP traffic, if that traffic comes in, the load balancer is going to have a job to do. It's going to distribute it to the back end. This is another thing that we'll set up in our demo. We are going to create a back end that is made up of a bunch of virtual machines in a virtual machine scale set. Now, in our demo, there will actually only be one virtual machine in the virtual machine scale set, but there are multiple ways that you could do this. You could have scale sets, or you could just set up individual VMs. If you use a global load balancer, you can even distribute those VMs across multiple regions. And that's really important from an availability perspective. Now you can even handle a region-wide failure. And we can always scale, right? So I mentioned virtual machine scale sets. Well, let's imagine that we've got the traffic coming through our load balancer and being forwarded to a group of virtual machines in a virtual machine scale set. Well, if those virtual machines start to get overwhelmed, we can have scaling conditions in our scale set to add more virtual machines. And because the load balancer is using the virtual machine scale set as its back end, anytime a new VM gets added, that VM is associated with the load balancer and can start taking on a portion of that traffic. Now, probably the most important part of all of these configurations is our health probes. So the load balancer is going to be regularly and frequently sending traffic to all of the systems on the back end. It's going to send out these health probes that mimic the traffic that should be going to the back end. So for example, maybe it'll send an HTTP request to the first web server, and that one responds, and yeah, we know it's healthy. And the same thing happens with the second one and the third one. So the load balancer is constantly sending these health probes to make sure that the virtual machines on the back end are actually working and responding. And if one of them fails to respond, the load balancer will recognize that fact and will stop sending traffic to it. And this is also effective if multiple virtual machines fail. It'll send the traffic to whichever virtual machines are still up and running. And this is probably the most important characteristic of load balancing, is the fact that we can have multiple virtual machines receiving this incoming traffic. But if one of those virtual machines fails, or if multiple VMs fail, the load balancer can detect those failures and direct all of the incoming traffic to the instances that are still working.